So this is literally, and I've shown you this for the time series, this is literally the marking template for bivariate. You can find this marking grid on Year 13 Stats Core. So you can go and look at this, look at the marking guide, look at how it's going to be marked. If you have a look, you'll notice it doesn't talk about residual graphs. Okay, so nowhere do you officially have to do it in a residual graph to get any of the grades. However, it helps, particularly for excellence, to be able to discuss the strength of the model that you've chosen. Okay, that's how we're going to discuss the strength of, particularly if you're going to look at a graph that is something other than a straight line, you'll need to draw a residual graph and look at how random the scatter is. So if when you draw a linear graph you see a pattern, that's not great. You would rather put either a cubic or a parabola graph, and hopefully on this residual graph there is a random scatter. The other thing in here is, the key thing for merit is this bit here: pose a comparative or comparison investigative question. So in your purpose statement, you're needing to say that you're going to compare, and for a lot of us, I know on Monday we looked at two graphs, but I'll show you a slightly different way of approaching it where you're still comparing two graphs but keeping the two variables the same. So this graph, as I said, we're going to be continuing talking about noisy classrooms, as a graph of the acoustic rating versus how many sick days a teacher has per annum. Okay, you can see here for poorly built classrooms with a low acoustic rating shows a teacher usually has 17 or say 15 sick days per annum. Okay, and as you get a better insulated classroom, probably like the one we're in, teachers have less sick days, up to sort of 5-6 days per annum. This data is color coded with blue being male, and if I go to the next slide, notice it's changed from male data to, sorry, that's female data, blue is female and red is male. Okay, so if I swap between them, can you see how the data changes between male and female staff, teachers? Which graph has a better relationship, or a stronger relationship? Female, eh? See, the blue, that graph hugs the trend line more than that one. I'm sure you just got the colours mixed up, but you see, I think we'd all agree that's a better linear fit than that one. Okay, so this is an example of comparing two graphs, which would be, enough to discuss the strengths for merit. So you could take it a step further and do a residual graph for both of these graphs and discuss the strength, and I'm sure that you would find the residual graph for this one the residuals would be smaller and better scattered than the residual graph for the male data, right? Continuing on with the comparison, this graph, by the way, has got it combined, male and female. Here's a third comparison, same graph, but we've got a third variable, and this is to do with the teacher's age. Okay, it's a bit hard to see on here, but the brown, this colour here, are younger teachers. So it looks like, and the purple over here are the older teachers. It looks like that the older the teacher, the more days off they have. Okay, so there's a third comparison or a third idea that you could discuss. What's this one? This one is class size. Again, the purple, large class sizes. Okay, so it also looks like the larger class, the higher the teacher absent days per annum. And this one is split by subject, and you'd have to have a closer look as to what was happening there. So on Insight, obviously you all know how to do that much. Remember to, if you wanted to drop the subset, you'd drop that gender in there. Okay, the other way to do that, by the way, if I just clear that for a minute, would be to go to add to plot, code more variables, and highlight gender in here. Okay. The way that I've displayed it earlier, you would also highlight gender in here. Okay, and that splits it up. Something that cost a few of you achieved in the time series was not actually doing your predictions well. Okay. Get summary. No, what I haven't done here is I haven't put a trend line on yet. So if I add trend curves, linear, does that put? Yes, it has. So now if I get summary, it's given me the equation for both those graphs. Really important. Without the equations, you can't achieve because you can't make predictions. So very quickly, if I want to make a prediction for the number of sick days, actually, by the way, we talked about the strength of the difference between male and female. See, the female has a negative 0.87 and the male has a negative 0.75. Does that correspond? Male has a weaker relationship than the female one. That was male, that was female. So that the correlation coefficient does correspond. Get rid of that. Coming back to my prediction, if you wanted to predict, say, the acoustic rating for a classroom rating of acoustic value 5, you would obviously put 5 into this equation. 5 times minus 1.88 plus 19.3 and appropriately round your answer. And it goes like this. It is predicted that with an acoustic classroom of rating 5, it is predicted that the number of days sick, and I can look at the graph actually and look to see if your answer is roughly correct. If I trace up where 5 is, your answer should be about 9 days, because it's going to be right on that line. Okay, so that's a good check for you to make sure that you've done your calculation correctly. What else? For excellence, these are the kind of things that you could discuss. Obviously, definitely residuals will be there. Removing outliers and then seeing how the equation changes and seeing how the R value changes. Okay, I'll do an example on this for classrooms, this one, Noisey classrooms, and I'll show it to you tomorrow. You definitely want to consider, or if it's suitable, consider another model, and you can see the two that are available to you. The two that are available to you on Insight are a quadratic and a cubic. Okay, I did talk about maybe using Excel. If you're familiar with Excel, go ahead and use other options. If you're not, I think at this point in time, I don't think we've got time to really go into using Excel. So these are the other two models that you could use. What else for excellence? You would also, I've written here, discuss extrapolation. Something, again, not done so well in time series was to discuss the reliability of your predictions. And that you've got to do that for merit. Another aspect to the excellence could be to discuss the implication of extrapolating, which means predicting outside of the data that you've collected. So you've got no evidence to say that your predictions are even possible or plausible, or whether the line starts to curve off or curve up, or so it's a discussion around, is extrapolation appropriate? And no doubt an excellence paper will have some research, and by research you need to actually back up your findings. So go looking for research that says, according to this investigation or this newspaper article, it was said that these were actual factors in teacher sick days. So that's what we mean by research, actually backing up your findings with research that's been done in the past.